All right, so turn, excuse me, turn in your notes to the 5.2 notes, and this time we're going to integrate, and this is new. It's not 100% new. I mean, we have done integration, and we have done things with natural log, but we haven't put them together yet, okay? But a lot of what I'm going to talk about, you're going to be like, no big deal. All right, I believe in your packet, that little part got hole punched out, so I'm going to rewrite this over here. In general, if you have 1 over x, or it could be any letter really, that you're integrating, that by definition is natural log of the absolute value of x. Okay, here we go. Natural log of absolute value of x plus c. Okay, this includes if this is written this way. Okay, we talked about this yesterday, but if you tried to integrate this using the old rules, what would your new power be? 0, and then you try to write the reciprocal of 0 in front, but 0 doesn't have a reciprocal. 1 over 0 doesn't even exist. Okay, so both of these things, by definition, equal the natural log of absolute value of x plus c. And if we had another letter, we would do that. So it's, in general, it's u prime over u, if that's what you have. A fraction where the top is the derivative of the bottom, that thing is a natural log after you integrate it, okay? So, look at number 1. First of all, look at that 5. What do you think we can do with that 5? It's just a number. Well, I'm not saying integrate it yet.
Move it to the front.
Move it to the front. We like to move numbers to the front, and I'm just going to put a 1 in its place. Because it's just, I took the 5 out, factored it out. You can think of it like that. All right, and I can do that with a 5. I couldn't have done that with an x, but I can do that with a 5. All right, now, this thing right here is exactly what we just talked about. And so my answer is 5 natural log of absolute value of x plus c. What we're going to repeatedly see today is that when you have integral 1 over x dx, or if it was any other letter, 1 over r dr, that's all the same thing. It's natural log. Okay, now with 2, it's a little bit different because I don't have just an x in the denominator. This is where we're going to use U-substitution. So in looking at what I see right here, what do you think we're going to let u equal? 5x plus 3, that's really the only part of the problem. So then du would be 5 dx. What do we do with the 5? Divide it over. And so this becomes 1/5 the integral. Now, remember, we replaced 5x plus 3 with u, so that becomes 1 over u. We replace dx with the 1/5 and the du. I've already written the 1/5, so we have du. So just like before, integral of 1 over u, du, that's just natural log of absolute value of u, and then plus c.
Do you have which one?
We do. I think I know what you're saying. We have to, our final answer is going to be, instead of u, we have to actually write 5x plus 3. Is that what you're, yeah. Your final answer should not have u in it. And remember, you can always check your work by taking the derivative of your answer, and you should get what you started with. Like in this case, you would have 5 over 5x plus 3, and then the 5 on the top would cancel with the 1/5 if we took the derivative. All right, number 3. So number 3, in going with the same thing, I can see that the denominator is more complicated than the numerator, and so I'm going to just go with what we've been doing, which is, well, with the one problem we've really seen, and I'm going to let u equal the denominator, and I'm going to show you what happens here, and then we can kind of talk about how you're going to see that like ahead of time. All right, so then du would be 2x plus 6 dx. Now, I don't have 2x plus 6 dx. I have x plus 3 dx. I can factor out of 2, right? and that makes that x plus 3 dx. But the 2's in the way, so we got to divide it over. Okay, so when you don't have exactly what you want, think about, well, how can I make that happen? A lot of this is just about like manipulation of the algebra. So in this next statement, I'm going to write the 1/2. Okay, the x squared plus 6x is in the denominator. So you have to write your u in the denominator. The x plus 3 dx, that gets replaced with the 1/2 in the du. And when you see this, integrate 1 over u du, you should be going, I know what to do next. Okay, you replace that with natural log of absolute value of u plus c. And then you do, if you had a substitution, which we did in this case, we take care of that by just looking up here and saying, what was u equal to? It was equal to x squared plus 6x. And again, we could check this, easily check this by taking the derivative. You may have to simplify the numbers a little bit, but you'll get what you started with. I do want to, before I continue, I do want to say something. Some people, when they look at me doing this, they think, why are you doing 1 over du? Okay? I can answer this a couple of different ways, but I do want to say this, like, I just want to write it down here. Like, some people think it makes more sense to do du over u. And for whatever reason, this makes sense to them better. That's the same thing as what I've written here. 1 over u times du is the exact same thing as the integral of du over u. They mean the exact same thing. So if this is making more sense to you, then you may want to write it that way. It just, everybody thinks differently about this stuff, so, you know, play to your strengths. Okay, number 4. We've done a few of these, kind of noticing a pattern of what to set u equal to. The denominator. And the reason it works is because the du part is the numerator. That's why it's working. Now, if this tan x was in the denominator and, like, I don't know, x squared was in the numerator, we'd have to approach that problem differently if that's even solvable. Okay, so what's the derivative of tan x? Secant squared x dx, which I have right here in the problem. That just gets replaced with du. So this is kind of what I was saying again. Some people are going to want to write it this way. Some people are going to want to write it like this. These two things mean the exact same thing. They both equal natural log of absolute value of u. So however you write it, that's what it equals. And then, of course, bless you, we do the substitution where we put tan x back in place of u at the end. And in all of this, don't forget plus c. Any questions so far? All right, so let's look at number 5 now. Do you guys think we should let u equal in number 5? And don't just think what we're doing today. Think of what have we been doing. What in number 5 makes you think you know what u should equal?
X plus 1 because it's inside of parentheses.
Because it's inside of parentheses. Okay, so let's do that. By the way, if you were thinking, hey, it should be x plus 1 squared, okay, I'll talk about that in a minute, but I want to just got to go through this. Because this is, we knew parentheses were our friend before. They're still our friend, that's not changing. All right, du then is going to be just dx. Okay, so I got the x plus 1 taken care of, that's a u. I got the dx taken care of, that's a du. But the 2 and the x, that's not anywhere over here. The 2 is easy. I can put the 2 out like this. But that x, I cannot do that with. I have an extra x. Toko. Don't you guys love Toko? No go? No one's ever said that before. That was pretty good. All right, so what is x equal?
U minus 1.
U minus 1. Okay, so in place of x, I'm going to have to write u minus 1. Okay, so let's just, this isn't our first TOCO problem, so I'm not going to write it down twice. I'm going to go straight to what we need to do. What's the power on u? It is squared, but it's in the denominator, so
Oh, okay.
-2. And then the u minus 1 gets multiplied to it. So you might be thinking, well, this isn't look anything like today's stuff. That's okay. It's fine. It will in a minute. All right, so then we got to distribute. So we have our 2, and then u to the -2 times u to the 1, that becomes u to the -1, right? You add the powers, minus u to the -2 times 1, that's u to the -2 du. And at this point, you can just integrate each piece separately. What's the antiderivative of u to the -1? So if we use our traditional integration rules, I'm going to write this down, but I'm about to erase it, so don't write this down. You would do this, and then you'd go, oops, that's a problem. That's because this is just a slightly different version. Let me go all the way back up at the top. Remember how we said 1 over x can also be written as x to the -1? So this is something you're going to have to kind of keep in your back pocket here. All right, u to the -1, that's the same as 1 over u. So what's the antiderivative integral of 1 over u? Natural log of absolute value of u. This is the part that's new today. If you're thinking, I'm never going to remember that, you will, because when you try to integrate this normally and you put a 0 there and you start thinking, what's the reciprocal of 0? You're going to know, I can't do that. Oh yeah, it's that we learned that, okay? That's what I'm hoping, right? Okay, minus. That was so specific. All right, so what's the power here on this one? This is a normal one. -1, and so if y'all comfortable if I just make that a +1 since it's 2 negatives? Okay, close those parentheses, write your plus c, and now we're going to rewrite it instead of u, we're going to write it with x plus 1, and that's it. You don't have to distribute the 2. Of course you could, but you do not have to. Hopefully you're writing just a little bit smaller than me. Okay, so TOCO problem with the new stuff, no big deal. Of course it's difficult. I know that. I'm not making light of it. But you can do it. All right, let's look at number 6. Okay, we got bounds. Okay, I'll deal with that in a minute. But what are we going to let u equal?
X squared plus 1.
X squared plus 1. We'll know in a minute if this worked. You know, when we get our du statement. It's quite possible we picked the wrong u. That's what your eraser's for. All right, du equals 2x dx. Of course, we're just going to move that 1/2 over. Go 1/2. And I got an x and a dx here, and I got an x and a dx in my problem, so that worked out really well. This becomes 1 over u, the dx becomes, the x and the dx become du. All right, what you got to take care of, though, in this problem is the bounds. Right now, the bounds are 3 and 0, and we need, and those are x values, we need them to become u values. And this is the equation I have for that. So if x equals 3, 3 squared plus 1, what's the u? 10. What about the lower bound? 0. What does that become? 1. Okay, so let's keep going. 1/2, the antiderivative of this is going to be natural log of absolute value of u, and then we're going to evaluate this on the balance 1 to 10. I didn't write plus c. Remember, we don't need plus c when we have bounds, because my final answer is going to be like a number. It's not going to be an expression with a plus c at the end. Okay, 1/2. I'm going to put a parenthesis here since I'm going to write more than one thing. So I plug in the 10. Now I dropped my absolute value bars. And that's okay. If you wrote them, that's not wrong either. The thing is, absolute value of 10 is 10. You don't need the absolute value bars because that's a positive number. If you wrote it, that would be okay. And this is your answer. Now, could you simplify this at all? Is there anything in here that you know what it is? Is. So probably if this was multiple choice, that wouldn't even be there. Okay. All right, so that's what you do when you have balance. We're just taking what we did before, and then it's just in a natural log problem. Okay, let's look at number 7. What do you think u should equal in number 7? Okay, I want you to watch, just watch what I'm going to do here. Okay, let's let u be x squared plus 1. Then du would be 2x dx. We would divide over the 2. And I have a very big discrepancy here. This can't even be solved really with TOCO. Okay, this is a problem. All right, so I'm going to erase what I just wrote. So I told you not to write it down. The way this problem is written is not working for me. And here's why. On all the problems we've done so far, the denominator was like bigger or had a higher degree than the numerator. Okay? These are the same. Okay, it'll also work this way if the top is bigger. Think about this fraction 5 over 2. You don't need to write this down. Is there any other way to write this fraction? How? We can write it as 10 over 4. We can write it as 2 and 1/2. Okay, let's really focus on this. One of these is an improper fraction. One of these is a mixed number. Right now, this is a fraction of polynomials, and we need to write it as a mixed number. Any ideas on how I can do this algebraically? Think back to elementary school. How did you know that 2 went into 5 2.5 times?
How many times 2 fits?
Yeah, what's that called? What is go into called? I'm trying to think, if you guys say it, maybe you won't hate me so much for what we're about to do. Yeah. So how do we do division of polynomials? We do this in log division. Okay.
Oh my god.
Don't freak out. Get mad at Krista. She's the one that said it, not me. Okay, so here's what I'm going to do. I am going to rewrite this problem on a new slide here because I really want to write big so that it's really clear. You either need to write small, like at the corner of your paper, or you need to turn over to the back of your paper. Okay? But we're going to have to do a long division. Now, here's a guarantee. However hard you remember this being, I promise you, after we go over this problem, you're going to be like, that's not as bad as I remember it. And I know that because that's what students always say. Okay? Y'all trust me just a little bit? No? Just a little.
Absolutely.
Okay, so this is how we're going to divide. We're going to divide the denominator into the numerator. And so we're going to go x squared, and then you may or may not remember this part. We need to not have like missing terms. It causes maybe things to not line up. Okay, let's make this go into the numerator. So x squared plus x plus 1. All right, and your very first step will be to divide. All right, so how many times does x squared go into x squared? Just one time. You can write the 1 here. You can say, no, the 1 should be above the number here. I don't really care. That doesn't matter. All right, then we multiply. So we multiply 1 times x squared. That's x squared. 1 times 0x. That's 0x. 1 times 1 is 1. Who remembers the next step? Subtract. So when I subtract, and when I taught this in Algebra 2 and Pre-Cal, I just changed every sign. I didn't write just 1 minus. If you're doing this right, the first column always cancels, and if you're lucky, another column cancels too. That happens a lot, but not all the time. Okay, positive x minus 0x, that's just a positive x. And hey, look, 1 minus 1, that canceled too. Okay, if it didn't, that would be okay, but it's nice when it does. So this is what we call the remainder. I can't go any further, so I only went 1 round, and that's how it is most of the time. Sometimes you're going to have to go 2 rounds, but that's it. All right, so then the way we write this is we write plus, we write our remainder over what we're dividing by. Okay, so this right here is the exact same as this. It looks different, but it's the same. It's like the 5/2 and the 2 1/2. Okay, any questions on that? Is it as bad as you remember it being?
Yes.
That's okay if you're honest and you say yes, but maybe not.
What was the other type of division?
Synthetic
Can we do
division.
that
But
one?
you can only do that when the denominator is just x plus or minus a number. And I'm actually not going to cover that because most of the time you're going to have to use long division, and long division always works. Okay, so let's go back to our problem. And what I want to do is rewrite this in this other form, which was 1 plus x over x squared plus 1 and then a dx. So I have 2 pieces now, okay? I got to integrate the 1 and I got to integrate the x over x squared plus 1. Okay, which one's easier to integrate? Like what I'm saying is you got 2 things here you got to integrate, and we're going to integrate them independently. That's what pluses and minuses do. It splits it up kind of into 2 problems. 1, what's the antiderivative of 1? So let's just go ahead and write that as an x. And let's just focus on integrating the second piece. So I want you to see what I did here. I'm supposed to integrate both pieces. I just said, let's integrate the easier piece first. Let's just do that. Then we focus on just this piece, and all the way through, on all my equals, I'm going to have x plus something, x plus something. At the end, my answer will be x plus whatever I get. And we actually have already done this problem. We just did it right up here. Okay? However, that was several minutes ago. So you might have forgotten. So let's over here do our little U-Substitution. So, and this is just a good practice anyway. So this is the first day we've done this. So let u be the denominator, x squared plus 1. Then du would be 2x dx. Divide that half over. So then my next line, remember I just said we're just going to do x plus. Now the 1/2 just goes in front of this integral because it came out of this integral. Okay, the x and the dx are right there, so this becomes 1 over u du. And I get that there's an x here and a u here, and I told y'all before, you're not going to have those in the same integral, and that's still true. These are 2 different, though, pieces of the problem. All right. So you should be feeling good at this point. At this point, this problem's downhill. We did the really hard part at the very beginning. Okay, 1/2. What's the antiderivative of 1 over u? Natural log of absolute value of u. So then your final answer is just going to be the same thing, but instead of a u, write the x squared plus 1. That's your answer. So that was kind of a nastier problem than the other ones, because you had to do the long division. All right, so that's not going to be every problem, but you're going to see it more than once. Okay. How are you feeling? You all right? You going to be okay? All right, number 8. I feel like 8's getting hidden over here. Okay. Remember, it's always, what is U going to be? And a couple of things, U is never going to be just X, and U is never going to be the whole thing. Okay? Now, it might be the whole denominator. Okay, so I'm going to purposely pick the wrong U. Don't write this down. Just watch what I'm going to do. I'm going to show you what happens. Again, what happens when you pick the wrong U? Well, your du, I'm going to have to use product rule, and I'm going to have a whole bunch of stuff. And I don't have any of that in my problem. That's how you know you picked the wrong U. Okay? So, does anybody have an idea of what the correct U should be? Which would just be part. Yeah, natural log of x. What's the derivative of natural log of x? Uh-oh. My pen's getting a little tired. 1 over x dx. So look, I have a 1 over x, and I have a dx. Perfect. So this whole thing becomes 1 over u du. And it's not just like it magically becomes 1 over du. These are problems that are set up to work this way. And when you get the 1 over u du, you know, hopefully, if nothing else, at the end of today, I want you to understand that this equals this. I want you to be really comfortable with that. And then always, of course, change your u back to what it was supposed to be. And we're not going to get freaked out one little bit that this is natural log of natural log. No big deal. We don't have to do anything with it. So yeah, it looks weird, but I didn't have to. It just was what it was. Okay, one more problem. Let's do this. Were there any of our 6 trig derivatives where you took derivative of something and you got just tan?
No, that's not.
No, it's not a thing. So like number 7, not that we're doing long division, we're going to rewrite. What's the easiest way to rewrite tan x? Okay, I could write it as that.
Sine
X over cosine x. Right? Does this make sense? Okay, the reason this is going to be really nice is because the numerator is the derivative of the denominator with a negative. Okay, we can deal with that. And vice versa. So you may not be sure. Should u equal sine x or should u equal cosine x? Well, if you pick the wrong one, you will figure it out because it won't work in the next step. Like you'll get stuck. But I'm going to go with what we've been doing today, and I'm going to let u be the denominator. Then du would be negative sine x dx. That negative gets divided over. And all of this works out really nice because see how cosine's in the denominator? That's where we get 1 over u. Sine x dx is right over here. Matches up perfectly. So du. Okay, so negative natural log of absolute value of u plus c. And then our final answer would be, instead of writing u, we would write cosine x plus c. Okay?